We are solving a system of equations here. A system of equations is where do these cross at? Where do they intercept each other at? Where's their intersection? So this is a parabola, that's an x squared equation. This is a line, so a parabola and a line can cross at two places. That's the easiest one, so the parabola could cross at two spots on the line, or it can just touch the line once, so it could have one solution, or the line and the parabola never meet at all. So let's see what our situation is for this one. And we're going to be using what we call the equal values method. That's when they equal the same letter, then they equal each other. When they equal the same letter, they equal each other. That's also called the transitive property. The transitive property says you can kind of skip over one if they equal each other. So I'm going to go ahead and show the transitive property on this one since I've skipped it on the other ones. So they both equal to y. So here's 6x squared minus 11x plus 12 equals y. Y equals 2x plus 10. Now here's the transitive property. It's like I can transport to the other one. So if these both equal y, then they can equal each other. So I can skip the middleman right here, basically. So we can skip the middle letter here since they equal each other. Notice everything looks equal, so I don't even need that y anymore. So I get 6x squared minus 11x plus 12 equals 2x plus 10. All right, do you remember what to do and how to solve when you have a degree of 2 or a quadratic? We need to set it equal to 0. Make everything on one side of the equation and just have a 0 on the other side. Then we can use the zero product property. So I'm going to move everything over to the left side so I can keep my x squared positive. I like to do that if I can. Minus 2x minus 2x. And minus 10 minus 10. 6x squared minus 13x plus 2 equals 0. All right, this is what I call hard factoring. It's a little bit more tricky. So I'm going to see if this even factors. We don't know if it does. In my mind, it looks like it does. So I'm going to show you my technique for hard factoring. Hard factoring is when you have a number not equal to 1 in front of x squared. Okay, we're still trying to factor it, but since I don't have a 1 in front of here, we have to use a different technique. All right, so the technique is, for me, is I take the x squared coefficient and the number by itself, or the constant, and I multiply them. So 6 times 2 is your first step. Now this is side work. All right, so I'm trying to figure out how I can break apart this and factor by grouping, which is a different technique. So 6 times 2 is 12. 12 is the number that we want to break apart. So I'm looking for what numbers now add to be the negative 13. So this still has the add part right here. What numbers add to be negative 13 out of when we multiply 6 and 2. So I go through all the factors. 1 and 12, notice a combination of that makes 13. 2 and 6, 3 and 4. So it's the 1 and 12 if they're both negative. Okay, so that's my side work. And I have 6x squared minus 13x plus 2 equals 0. Okay, so I use these two new numbers to break apart the negative 13. So 6x squared, I use a negative 1 and a negative 12. That makes negative 13. That's what I want. They multiply to be positive 12. So everything links together. So this is negative 1. It doesn't matter the order here. It'll work out. X and negative 12x plus 2 equals 0. Notice all I've done here is I've just changed negative 13 into a negative 13x into a negative 1x and a negative 12x. So that's the only thing I've done here is I've converted it. I don't want to go too far. The negative 13 has changed into those two numbers. Okay? So those numbers are special in a sense that it allows me to factor by grouping so that I can take it to the next step. Factor by grouping here is I'm looking at the greatest common factor. I'm looking at a factor here that these can kind of have in common separately. Okay? So first, I'll look at the first one. What does 6x squared and negative x have in common? They have an x in common. What's left is an x minus 1 right there. 6x minus 1. Sorry about that. 6x minus 1 is what's left. I like to just distribute to make sure. It's really easy just to check your work. X times 6x, 6x squared, x times negative 1, negative 1x. Okay. I do the same thing over here, but the trick is make sure you pick a number so this part matches. So you just got to look ahead a little bit. This is that case where you got to be careful. I factor out a negative 2 here. If I factor out a negative 2, then negative 2 times what is negative 12x? Negative 2 times 6x is negative 12x. Negative 2 times what is positive 2? Negative 2 times negative 1 is positive 2. All of this is still equal to 0. Now, the whole point of this is so that you can have this matching factor right here. So then I look at, it's separated by the minus sign here. So these are the two terms that we have. What's in common with the two terms? The 6x minus 1 is in common. What's left? If I pull this out of the first term, what's left? Just the x. If I pull this out of the second term, what's left? Just the negative 2. So I've now factored it, which is the hard factoring technique. Okay. So now you're letting each one equal 0. Well, this one you should be able to see, right? When is this equal to 0? If x is equal to 2. Now, don't do this in your head. Be careful. A lot of times you make mistakes. Just take it through the process. 6x minus 1 equals 0. I want to know when this is equal to 0. So I set it equal to 0 to solve so I don't make any mistakes. Plus 1, 6x equals 1, divide by 6, divide by 6, x equals 1 over 6. All right, I have two solutions here. Remember, this is where it's crossing in space somewhere on the coordinate plane. So I'm missing the y values. Don't forget we want a coordinate or ordered pair solution. So which one's easier to deal with? Which one is easier to plug in your x to find your y? Definitely I'm going to go ahead and focus on the non-quadratic. I'll focus on the linear. So let's go ahead and find out each one. I'll do the easiest one first, x equals 2. When x equals 2 for y equals 2x plus 10, I'm plugging 2 in for x. Y is equal to 2 times 2 plus 10. 2 times 2 is 4 plus 10. 14. Got 14. Don't forget to write it as an ordered pair. This would be the 2 comma 14 point. Okay. Go ahead and get rid of some of my work over here. Let's do the other one. When x equals 1/6, what's its corresponding part? For y equals 2x plus 10, we're plugging 1/6 into there. Y equals 2 times, sorry about that. Y is equal to 2 times 1 over 6 plus 10. This is equal to 2 over 6 plus 10, which is equal to 1/3. 2 goes into 2 once, 2 goes into 6 3 times, plus, let's change 10 into a common denominator with 3. So what would 10 be as a common denominator of 3? 30. 30 over 3. All right, just making my life a little bit easier. 1 plus 30, we combine the tops and the bottom stays the same, and I get 31 over 3 for the y value. Now, do you know where 31 over 3 is at on the y? Well, it's easier for some of these to write it as a mixed number or as a decimal. So this would be equal to 3 goes into 31 10 times with 1/3 left over. 1/3 is 3, 3, 3, going on forever. So yes, I do know where 10.3 is. I don't know where 31/3 is. All right, so this is our ordered pair now. Our ordered pair is, the x value is 1/6, 1/6, comma, the y value is, I have this as a fraction, so I'll write it as a mixed number, 10 and 1/3. Okay, that's the same thing as what I got here. Okay, got it. So one thing I just kind of, so these are our two solutions. Let me write them over here. I want to try one more type of method. I want to see if I can remember how to do it. So 1/6, comma, 10 and 1/3 is one solution, and 2, comma, 14 is the other solution. All right. So the other thing I wanted to try to do, and let's see if we can or not, if the, and it's worth a try, so maybe you can finish it if I can't, but I want to give it a shot. So let me go ahead and get this out of the way. There's a couple different ways that we can try to factor this. So this is one method right here. This is the method that kind of just jumps in my head that I'm pretty good at. Another method, and I'm trying to factor 6x squared minus 13x plus 2. Now, I know it factors, so it turns into this right here, but I want to try a different method. So this was what I call a factor by grouping method. So I want to try a generic rectangle method. All right. So the generic rectangle method sometimes is a little bit easier for students to deal with. We're looking for what goes in on the outsides here. So this is missing, this is missing, this is missing, this is missing. So if I do it right, I should have like 6x minus 1 and x minus 2, or the other way around, x minus 2 and 6x minus 1, if I do it correct. Okay, so let's see, if I remember right, it would be a 6x squared is right here, and a 2 is right here, okay? We multiply these together, 6x squared times 2, and I get 12x squared. And then we're looking for what numbers can we put here that go into 12 and add to be negative 13. Okay? So, what two numbers? We do a diamond problem at this stage. The diamond problem is what two numbers multiply to be positive 12 and add to be negative 13. What two numbers multiply to be positive 12 and add to be negative 13? Well, we just talked about this. Negative 1 and negative 12. Negative 1 times negative 12 is positive 12. Negative 1 plus negative 12 is negative 13. These two numbers are the numbers that go inside your box right here. So negative 1 and negative 12x. Okay? So you can kind of include the x there if you wanted. So it would be add to be a 13x, negative 13x, multiply to be a positive 12x squared. There's our x there, if you wanted to. I just think about it in the sense of the numbers, and then I make sure I add the x's when I do this. Okay, so this is the way that another approach. Notice it's the same numbers that we found right here, and the factoring goes in what's in common for each of these to fill in these blocks. Okay, so the greatest common factor of this line right here, can you see it? Is a 6x. The greatest common factor right here for this is a 6x. That's in common here. Then you start filling in the other spots. I like looking at this spot next. So 6x times what is 6x squared? Well, 6x times x. 6x squared, that's that spot. Once you have 1, you can fill in the rest. So x times what is negative 1x. X times negative 1 is negative 1x. And then 6x times what is negative 12x. That would be a negative 2, I believe. 6x times negative 2 is negative 12x. Check. And then this is the check, confirm that everything's correct. If you fill these in, then this one will be okay. Does negative 1 times negative 2 make positive 2? It sure does. So what this does is it gives you another way of factoring. So these are your answers right here. The 6x minus 1 times x minus 2. Okay? So notice that confirms with what I got right here, the 6x minus 1 times x minus 2. It's a different way of factoring. This is the generic rectangle. Some students like dealing with that a little bit better. I personally like the factor by grouping technique. Students sometimes struggle with the idea of the factor by grouping. If you're not very good at pulling out a common factor, a greatest common factor, then this one's a little bit more difficult for you. That's why this one is set up to be a little bit easier, because you're not pulling out a greatest common factor, you're looking for common factors, and it fills in and links together a lot easier.